Most remote sensing data and all the kinds of data we would refer to as a satellite image, they come in the form of what's called a raster. A raster is a very simple structure that we have for the data. It's a grid that has a number of columns and a number of rows which combine to form cells. I'm drawing a really small one here, but most satellite imagery has thousands of columns and thousands of rows, and as a result it has millions of cells. When we deal with imagery, we often call the cells pixels as well. You can use those two terms interchangeably. In a normal grayscale image, each of these cells then has a number. If we imagine an 8-bit image, the cells can have values that range from 0 to 2 to the power of 8 minus 1. So 0 to 255. Some of the older satellite images that we deal with, they actually come in 8-bit format. Most newer images, they come with 11 or 12-bit resolution, and then the files you get are typically 16-bit, so they can have a lot of different values in each cell. But if we imagine that we're working with an 8-bit image, each cell has a value. Typically I'm not going to write all the values, but you can imagine all these cells, they have different values here. If we've taken an image of a very dark surface, the pixel that has recorded that dark surface is going to end up with a low number. 0 if it's as dark as it could possibly be, but otherwise a low number. And if we have a very bright surface, maybe down here, we will have much higher numbers. If we show this grid on a computer screen and we display the cells with large numbers with high brightness and the cells with low numbers with a low brightness, you can imagine that they combine to form an image. So this is the fundamental form in which we store satellite imagery, but most satellite imagery doesn't come in grayscale form. So if we want imagery that's in color, we need additional grids. So you can imagine, I'm going to draw them smaller now, but you can imagine that you have additional grids, and each grid has a set of numbers in them. If we have normal color imagery, we will have one grid that stores the brightness in the red wavelengths. And we'll have another grid that stores brightness in the green wavelengths, and one that stores brightness in the blue wavelengths. And when we combine all of these, display them together on a computer screen, we get a color image. Much satellite imagery has much more than these 3 bands. So for example, Sentinel-2 imagery that we'll work with in this course, it has 15 different bands. So that gives us 15 different grids, and we can display them in all different combinations. One last thing that's really useful about the raster format is that for satellite imagery, unlike the images you take with your phone, we want to know the exact location of where that image was taken. So what we want to know, for example, is where is this pixel on the Earth's surface? And where is that pixel, obviously, and where is this pixel? We need to know this so that we can overlay different images properly on each other. We can overlay an image on a map. We can put it onto Google Earth, for example, things like that. So there's a little bit of additional information in addition to all the numbers. It's additional information that we need to have for a satellite image. The way that's typically stored is that we have an XY coordinate for the top left pixel in the image, so we know where that pixel is. And then we have a defined cell size, which means we know if we move one pixel over here, what is the XY coordinate of this pixel? And if we move another pixel over, what is the XY coordinate of this pixel, and so on. The last piece of information we need to have to know where this image is we need to know what these x and y coordinates mean. So we need to have a datum and a projection that they refer to. In the Ottawa area, for example, you could imagine that the x and y coordinates refer to UTM zone 18 north, which is the one typically used for Ottawa. And we should add a datum to that. We typically use WGS 84 for satellite imagery.